Our today's topic is the continuation of the calorimetry part. In the first video, we had discussed heat, temperature, specific heat capacity terms related. Now, in this video, we are going to do calorimeter. So, calorimeter is a device used to find the amount of heat gained or lost whenever two objects with the different temperatures are mixed together or kept in contact. So the amount of heat gained or lost is determined using an apparatus that is called calorimeter. Okay, first of all we will understand the structure of the calorimeter, then how we find the heat gain or loss. So first of all, to explain calorimeter, so you will find this kind of a structure. It will be this kind of a structure. It is nothing but a simple vessel. It is a simple vessel made up of copper. You can see it. It is a copper vessel whose inner portion is painted, which inner portion is made polished, silvered. And you always know whenever a object is made silver, whenever any portion is made silver, polished, that means what? This is done in order to prevent the heat loss by radiation. So whenever to prevent the heat loss by radiation is to be required, so we make any of the surface polished. So it is copper vessel. First of all, I am explaining the structure, then we will explain the heat loss gain, how it is done. So it is a copper vessel which after this copper vessel it is kept in a wooden frame to provide it the rigid support, wooden jacket. So outer surface of the calorimeter, from outer surface we are explaining it. Outer surface of the calorimeter is provided with a wooden jacket in order to provide it rigidity, in order to provide it a strength. Okay. After that copper wooden jacket, it is filled with, between the copper vessel and the wooden jacket there is a gap, and that gap is filled with a insulating material, wool or wood dust, whatever the material, or cotton, whatever the material we can fill it with. Thermocol we can fill it with. That means any of the insulating material we can fill in between the gap of the copper vessel and the wooden jacket. So we understood that it is provided with, first of all, the outer surface is made of the wooden. Then after that between the wooden and the copper vessel, it is the copper vessel, a thin copper vessel, thin, not the thick but thin. So between the thin copper vessel and the wooden jacket, the space is filled with insulating material. That means what? It is filled with either wood, cotton or the thermocol, whatever the material we have, we can fill it with any of the insulating material. Then we have a layer of thin, not layer but we have a thin copper vessel. Inside it, upper portion of it is covered with wooden lid. So wooden lid is placed at the top of it, and there a thermometer is placed in order to record the temperature change. So temperature change, to record the temperature change, it is provided with a thermometer, and to ensure the heat can get hot and the cold object get mixed thoroughly, so for that one we have a stirrer, and a stirrer is continuously moved in order to or quickly make the hot and the cold liquid, hot and the cold objects mixed quickly together. Okay, so that for that purpose we have the stirrer. Now we have some terms in calorimeter. It is ensured to avoid the heat loss by conduction, convection and radiation. There are the three, radiation. So there are the three ways in which the heat get lost from a calorimeter, that is the conduction, or generally heat get transmitted only by the three method from the any of the surface, that the conduction, convection and the radiation. So first of all I am coming to the conduction, then convection and then the radiation. Okay, so from the radiation start. From the radiation, because you will understand it from the inner portion, I am coming to the outer portion. So in order to stop the heat loss by the radiation, so if in any cases we need to means stop the heat loss by the radiation, so under that situation we do only one thing: make the surface polished, make the surface silvery. In thermos flask you will see the same thing, in a calorimeter you will see the same thing, or if any of the object, if any at any surfaces it is means needed, if it is needed to means avoid the heat loss by radiation, so under that situation we will make the surface polished, silvered. So we will do the same thing. So inner portion of the calorimeter is polished, highly polished surface. Why? In order to means avoid the heat loss by radiation. So in order to heat radiation is avoided, heat radiation is stopped, heat loss by radiation is stopped by making the inner surface of it is polished. Okay, then conduction. So between the wooden, obviously from the wooden to the copper, so all the way it is the insulating material. That means it will not entertain the heat loss by means any kind of heat loss. It will not absorb loss. You know very well that if it is the insulating material, it will not absorb heat. So under that situation, as the material is insulating, that means what? It will avoid the heat loss by conduction. So in order to avoid the heat loss by conduction, so between the copper vessel and the wooden jacket means space is filled with insulating material. And the third one, convection. Obviously convection occur only when there is the movement of the surface. That means the hot liquid and gases move, molecules move upward, downward, only in that case, and that will take place inside the liquid. So in order to ensure the heat loss by convection, calorimeter, the upper portion of the calorimeter is provided with a wooden lid. So we place a wooden lid at the upper portion of the calorimeter. So this one is the structure, and the sum means how heat loss is stopped in calorimeter, so that it can be ensured that there is the only exchange of heat between the hot and the cold material, whatever we will pour inside the calorimeter. Obviously, then the calorimeter is always made of the copper. So yes, copper, in science each and everything has a fact, and we need to understand that fact. Means calorimeter is always made of the copper, and there is a reason behind that why calorimeter is always made using copper vessel. So the first thing, good conductor. So copper is a good conductor of heat and electricity, both, also heat and electricity. As the copper is a good conductor, so what happened? It easily acquire it as soon as the mixtures are poured into it, hot and the cold mixtures are poured into the calorimeter. So as soon as it required it acquire the temperature of the mixture, and so it become very easy to calculate the heat gain or loss, easily acquired. So the experiment can be done very easily. So due to its good conductivity, copper soon acquire the temperature of the mixture, the hot or the cold mixture, whatever being kept in the vessel. So first, that is the first reason. And the second one, low specific heat capacity. Copper has very low specific heat capacity. Okay, means while describing a specific heat capacity, we have discussed something. If any of the substance has high specific heat capacity, under that situation it will absorb large amount of heat in order to increase a particular temperature. But if a substance has a low specific heat capacity, that substance will absorb less amount of the heat in order to get up to raised up to the same temperature. So copper has a low specific heat capacity, and that is the other advantage. So that fit it for the calorimeter, that if it has a low specific heat capacity, that means it absorb a little amount of heat, that means negligible amount of the heat to get temperature of that object, get temperature of the mixture. So that is the other advantage. As low specific heat capacity of the copper, make it to absorb a little amount of the heat to attain the temperature of the mixture. So that is the other reason, so due to which we make calorimeter always using copper. Okay, how we calculate the heat gain and loss in a calorimeter? So we have a formula we have discussed here from the heat capacity. C equals to mc del theta, mc del theta, that means theta is the temperature rise or fall. So whenever hot and cold liquid are kept in contact, we use two formula. So C1 equals to M1 C1 del theta, and other is heat lost or heat gain, because means okay, and the other is C2 equals to M2 C2 Q equals to, sorry, C not C, Q equals to, है ना, Q equals to MC Q1, that means either it is heat gained or heat lost. So Q equals to MC del theta from the hot object, suppose it is for the hot object, and the for cold object it will be also Q2 equals to MC. So M1, so it is the Q1, and Q2 it is hot object, hot, and for Q2 cold object, suppose it is the क्या जाएगा Q2, so that Q2 equals to M2 C2 del theta. So it will be the heat gain and heat loss, and finally we can compare Q1 and Q2, we can find the heat gain, heat loss, or whatever the quantity we have been told to find out. Okay, next one, that the principle of calorimetry, principle of mixture. So principle of calorimetry states that the heat gained by an cold object when, principle of calorimeter you will write in such a manner. Principle of calorimeter states that whenever the two objects with the different temperature are kept in contact, heat lost by a hot object is always equals to heat gained by a cold object if there is no loss of heat in the surrounding. So if 10 joule of heat is lost by a hot object, that 10 joule of heat will be absorbed by the cold object. So that is the principle of calorimeter. And the principle of mixture states that whenever, there are also principle of mixture, principle of mixture states that whenever two objects with the different temperature are kept in contact, there is the flow of heat from the hot object to the cold object till the temperature of both become equal. So that is the principle of mixture. So calorimeter, we now in this video we understood calorimeter, principle of mixture, all these one. In next video we will discuss next topic of the calorimeter.